All right, let's wrap this up. In part D, for the time interval 20 less than or equal to t less than or equal to 30, at what time does the temperature of the water in the tub reach its maximum temperature? Not what is the maximum temperature, but when does the temperature reach its maximum? So here's what I know. I know I'm only looking on the time interval 20 less than or equal to t less than or equal to 30. I know that W prime of t represents the rate of change of the temperature. And what else? And I want to know the maximum temperature. Well, this is a calculator active question. Let's go back to the graph. Let's go back to the graph. There's the graph. So this represents the graph of W prime of t on the time interval 20 to 30. What I can see is initially W prime of t is above the x-axis, meaning that the rate of change is positive, and then eventually the rate of change is negative. At the point where W prime of t changes from positive to negative, the graph of W of t is going to have a relative maximum temperature. Let's go find that value. So we're going to do menu. We're going to go to analyze graph. We're going to find the 0. We go a little bit to the left. We go a little bit to the right. I'm seeing 26.2. That's not going to be accurate enough. So let me see what's going on. I'm going to go to menu. I'm going to go to settings. There's the problem. I'm in float mode. I need to be in fix mode. So scroll down to fix 3 or higher, make that the default. And I'm going to get 26.180. So let's go back to what I'm writing. At t is approximately 26.W80, W prime of t changes from positive to negative, which implies W of t has a relative max. That's not the same as the absolute maximum, but we do know that we've established that the function W of t is going to have a relative maximum at 26.180. Let's go back to the graph one more time. On the time interval 20 to 30, the graph of the derivative changes sign just once. So what that means is from 20 until 26.180, the graph of W of t is only ever increasing. From 26.180 to 30, the graph of W of t is only ever decreasing. If I were to sketch that, then I would say, okay, my graph, here's time t equals 20. My graph increases, and that's all that it does, until we get to 26.180, and then my graph decreases, and that's all it's allowed to do. So not only do I have a relative maximum at 26.180, but this has to represent the absolute maximum temperature. The write-up is going to look something like this. On 20 less than or equal to t less than or equal to 30, W prime of t changes sign only once. Therefore, W of t has an absolute maximum at t equals 26.180. Oh, not degrees. Sorry, what are the units here? Oh my gosh, it's been such a long time. The units are minutes, not degrees. Awkward. So in terms of awarding the point, the identification of 26.180 as important, because W prime of t changes from positive to negative, gets you 1 point. And then you're being able to justify not using the sketch that I have over here, but writing it out in words, that on the time interval 20 to 30, W prime of t changes sign only once, therefore W of t has an absolute max. That gets you the second point. So this, my friends, is worth 2 points in part D. It's this right up at the end that always seems to be a little bit tricky for calculus A, B, and BC students. So if you can really look over this, make sure you understand what's going on, that's going to help you out tremendously. And we're done.